So Jackson, we're doing Unit 3, Day 13. We're going to just do the first example, and I'll make a video for the second example for later on. Okay, so here are the answers for, well, here's an answer for A, how about? So you'll notice here that I maybe did not show, oh, it's frozen, sorry. You'll notice here that maybe I did not show as much work as you would expect, but assuming that my numbers are right, assuming I didn't push the buttons on my calculator wrong, this would be plenty of steps right here. Remember, the calculator is active, and so there's no need really at this point for me to figure out what e prime of t is. If you did, it's fine. But if you just used Math 8 to figure out e prime of 25, and I'm hoping that I pushed the button on the calculator right, and 0.397 really is the right number. And then, of course, you have to figure out what the point of tangency is to e of 25. And then you put that into your point slope form. You really just have to have those three things in there. So as you think about strategies and such, if this were a quiz, and again, assuming the numbers are all right, this would be full credit. There's no need to do anything else. You know, sometimes you feel kind of guilty or a little uneasy about, oh my gosh, should I be showing more work? You know, if the calculator's active, this really, you have to have numbers that are labeled, but it really allows you to not have to show all the in-between steps. If the calculator's not active, then yes, you do have to show all the in-between steps, because otherwise, how would you even know what to do? But here, Math 8 is very handy. Evaluation is very handy. Do you have any questions on 1A? Proud of you guys. This is feels like the 1000th time we've done a tangent line equation. Just looking at your body language and looks on your faces, it feels like you're getting really comfortable with this. Okay, so then part B told us that we were supposed to use that tangent line to do some estimating. So there's an answer for B. So notice how I just took that previous tangent line and I plugged in 30. And again, assuming that I had pushed all the buttons in the calculator right, I came up with an estimate for e of 30 to be 34.206. See that on my second line there? And again, I'm using the calculator heavily here. I'm just plugging in a number and doing some multiplying and adding and subtracting with my calculator. I'm not feeling compelled to show any of those in between arithmetic steps. Any questions on the 34.206? Okay with that? Alrighty, so then I'm asked to determine whether that is an overestimate or an underestimate, and in order to do that I have to figure out what e double prime of t is, because I need to be able to figure out the concavity of e. And so I find e prime on my way to finding e double prime. Did y'all do the quotient rule? Or a product chain combo? Yeah, question.
Did you just plug in e of 35 or e of 30 and then compare that to your tangent?
You mean e double prime of 30?
Well, no, just instead of doing the prime. Because you have the tangent line, just find that e of 30.
Sure. Yeah, good question. You know what? And to be honest, I didn't make this terribly clear in the instructions. I really didn't. And so, based on that kind of thinking, I think that that's pretty reasonable just to say, hey, look, I calculated it, and here's the relationship. Yeah. Right? I would say, based on the way that I've worded this, it would be hard to deny that answer. You can tell what I was going for, more along the lines of what we did last time. And so, like on a quiz or a test, I'm gonna box you into a corner. I'm pretty careful with my wording on these, but I'm really careful with my wording on a quiz or a test because I'm trying to measure something. On a quiz or a test, you're gonna have to use that second derivative to say, all right, the second derivative is negative for this interval, therefore e is concave down, perhaps you would say, therefore the estimate is too high. I don't want to push you that way, but based on the way that I worded this, I don't know that I could really expect you to do anything different than what you did. Yeah.
So since the calculator was active, I just plugged it in and did the graph.
Yeah.
And I just said that based on the graph, it's concave down.
So you want to be super careful with that because graphs can lie to you. They can look one way and be a different way. And so I would say, in general, if your reasoning is, if your reason is absent of analysis like this, and you just say, hey, I looked at the graph, and it's concave down, I'm not going to take that simply because I can do a graph for you that depending how far you're zoomed in or out, it'll look one way, and then you zoom in or out and it looks totally different.
Uh-huh.
So it's not as reliable as we'd want.
Okay.
So try to use analysis like numerical and expression analysis like this to get there.
Okay.
Good questions from everybody. Anything else that I can help you with? Okay. So then I wanted to talk through C and D with you. C is really similar to the one we did last time, and I thought that talking through it might be a good thing to do. It looks like Hunter's done writing. Okay, so C. C says, is the amount of water in the tank increasing or decreasing when T is equal to 100? So if I'm going to use some really general words here. If I say, is something increasing, what might you try to analyze?
The amount of water.
Say again?
The amount of water in the tank?
No, because if I just know the amount of water, that doesn't tell me whether it's increasing or not, right? If I just said there's 500 gallons in the tank, is it increasing or decreasing? It's not really enough to go on, right? You'd have to know what about the amount of water?
Change the amount of water?
Not just the change, but let's say again? The rate of change, right? That's exactly right. And then when we're in calculus and we're talking about rate of change, what are we really talking about? Derivative. So if I ask you, is something increasing, what I want you to think about is something prime positive or negative, right? So if I say, is the amount of water increasing or decreasing when t equals 100, I'm really asking you, is amount prime positive or negative? Okay, so do we have any information about the rate of change of the amount of water? What do we know? What do we have? Luke.
Two functions.
And the two functions are describing what?
Gallons per minute.
And a gallons per minute is a unit for a?
Velocity.
There's no velocity here. Nothing's moving around. I know we want to say that. Like if we're very physics oriented, we want to say that. But there's no velocity. There's no acceleration. There's no position here. It's just water flowing into or out of a tank, right?
The rate.
It's the rate of flow, rate of change of the amount of water. Yeah. Don't we have, like you said, two different rates here? And we need to recognize, first of all, that these actually are rates. They're not amounts. And the E of t is causing the water in the tank to increase. L of t is causing the amount to decrease. Did anybody think of a way to relate these appropriately so that we could figure out, is the amount increasing or decreasing? Anybody think of this?
Find the derivative of both at t.
So here's the problem with that. If I find the derivative of E of t, I'm ignoring the fact that E of t is already the rate of change of the amount of water. So if I were to differentiate this and get E prime, wouldn't that be the rate of change of the rate of change of the amount of water, which actually is going to be a thing in D, right? Do you remember me saying this last week? That in a question like this, the true test of understanding is realizing that E of t and L of t are already the derivatives of the amount of water. They're already the rates of change of the amount of water. And so the wise move would actually be to leave them as they are. Are you with me? So what I would do with this for C, if I'm trying to figure out if the amount of water in the tank is increasing or decreasing, I'm going to calculate the numerical value of E of 100 minus L of 100. I'm not going to find E prime. I'm not going to find L prime because E and L are already rates of change of the amount of water. Okay? If E and L were somehow like related to the amount of water, then I would need to do a derivative, but E and L are already rates of change of the amount of water. So I'm just going to leave them as is and evaluate E of 100 minus L of 100. This will tell me what I need to know. Hi. Anybody know why I did E minus L instead of E plus L or L minus E or some other variation on that?
Because when you leave the tank, you subtract the water.
Yeah.
Is that it?
Yeah, L is causing the amount to decrease, and so we would be subtracting that, right?
Right.
Yeah, totally. And then E, of course, is causing the amount of water to increase, so we would make that a positive rate, right? Rate in minus rate out. Has anybody had a chance to figure out what this actually is?
-4.
-4. Let's go 3 decimals if we can.
-3.946.
946?
Yeah.
Okay. For our purposes, we want to have an accurate number there, but for our purposes, what's the most important thing about that number? It's negative, the minus, right? So this is a negative number, so we can actually lead right into our conclusion. We can say, therefore, the amount of water is what? Increasing or decreasing? Decreasing, yeah, there we go. Decreasing at t equals 100. And we would leave it at that. Okay. So this is a classic water tank question. I left it in the form of a water tank, but it can take on all kinds of forms. The big concept is essentially rate in minus rate out. Okay. You guys good? Okay, cool. So I'll do D and the other one on a video. Let's go ahead and build a fort.